Partial fraction decomposition. What is partial fraction decomposition? Well, it's the process of taking a simplified rational expression and breaking it apart into the sum of two or more simpler fractions. For example, we know that the sum of 1/2 and 2/5 is 9/10. Well, with partial fraction decomposition, we would start with the 9/10 and then break it up into the sum of 1/2 and 2/5. We will use this process for an integration technique termed integration by partial fractions. Well, how does partial fraction decomposition work? Well, we'll start with some rational expression, some f of x divided by g of x, and we want the following to happen. We first want the degree of f to be less than that of g, and then we want to be able to factor g into linear or quadratic factors. If this is the case, then we'll go ahead and factor g as some p times q, and then rewrite our original expression as follows. We'll rewrite f of x divided by g of x as some unknown value a divided by the first factor of g, p, and another unknown b divided by the second factor of g, q. We'll then use algebra to determine the values of a and b. We'll look at an example. We're asked to expand 7x plus 1 divided by the product of x minus 5 and x minus 3 using partial fractions. Well, we'll notice that our denominator is already in factored form, so we'll go ahead and rewrite the original expression as the sum of those two factors. We'll rewrite as a divided by the first factor, x minus 5, plus b divided by the second factor, x minus 3. Now we'll multiply both sides of that equation by the least common denominator so that we're able to clear the fractions. In this example, our least common denominator is the product of x minus 5 and x minus 3. We want to simplify that expression. Over on the left side, I am able to cancel the product x minus 5 and x minus 3. Over on the right, the first term, I'm able to cancel the factors of x minus 5, and in the second term, I'm able to cancel factors of x minus 3. I'll distribute on the right side, distribute the a through the parentheses, and I end up with ax minus 3a. Distribute the b, and I end up with bx minus 5b. Collecting like terms on the right side, the terms with x's are like terms, and then the term without x's, my constant terms, can be grouped together. Ax plus bx I put together, and then negative 3a minus 5b also go together. Because ax and bx both contain a factor of x, I can factor the x out and rewrite it as the sum of a plus b times x plus the constant term, negative 3a minus 5b. I'll now use equality to determine the values of a and b. On the left side, I see that x has a coefficient of 7. Well, this means that the coefficient of x on the right side, a plus b, must also be equal to 7. Also, the constant term on the left side is 1. This means that over on the right, the constant term, negative 3a minus 5b, must also be equal to 1. That information gives me a system of equations. I know that a plus b is equal to 7, and negative 3a minus 5b is equal to 1. Multiplying equation 1 by 3 and using the process of elimination, I get that negative 2b equals 22, which means that b must be equal to negative 11. I'll replace b with negative 11 in the first equation and get that a must be equal to 18. Thus, I was able to decompose 7x plus 1 divided by the product of x minus 5 and x minus 3 as 18 over the first factor x minus 5 plus negative 11 over the second factor x minus 3. Example 2. I want to expand this rational expression using partial fractions. This time my denominator isn't factored, so I'll go ahead and factor x squared plus 8x plus 12 as x plus 6 times x plus 2. And then I'll rewrite my original expression as the sum of those two factors. I'll rewrite as a divided by the first factor, x plus 6, plus b divided by the second factor, x plus 2. I'll multiply both sides of the equation by the least common denominator. In this case, it's the product of x plus 6 and x plus 2. I'll need to simplify this new expression. On the left, I'm able to cancel factors of x plus 6 times x plus 2. The first term on the right, I'm able to cancel factors of x plus 6, and in the second term on the right, I'm able to cancel the factor of x plus 2. I'll distribute over on the right side, collect my like terms, place my x terms together, and then my terms without x's, my constant terms, 2a plus 6b, I'll group those together. I'll use equality to determine the values of a and b. On the left side, I see that x has a coefficient of 5. This means that the coefficient of x on the right side, a plus b, must also be equal to 5. Also, the constant term on the left side is 38. This means that the constant term on the right, 2a plus 6b, must also be equal to 38. I'll again solve the system of equations. I know that a plus b is equal to 5, and 2a plus 6b is equal to 38. I'll multiply equation 1 by negative 2 and get that 4b equals 28 through the process of elimination, which means that b must be equal to 7. Replace b with 7 in the first equation, I get that a is equal to negative 2. Thus, my partial fraction decomposition of 5x plus 38 divided by x squared plus 8x plus 12 is negative 2 divided by x plus 6 plus 7 divided by x plus 2. My final example, I'm asked to expand x plus 7 divided by the quantity x plus 1 squared using partial fractions. Because the factor in the denominator is quadratic, I'll have to rewrite my original expression a little differently this time. What I'll have to do is rewrite it as the sum of a linear and quadratic factor. So I'll rewrite as a divided by a linear factor of x plus 1 plus b divided by that quadratic factor of x plus 1 that appears in the original expression. This technique is one that's used whenever there's what's called a repeated factor in the denominator. I'll again clear my fractions by multiplying both sides of the equation by the least common denominator. In this case, it's the quantity x plus 1 squared. Simplify that expression. On the left-hand side, I'm able to cancel factors of x plus 1 to the second power. In the first term on the right, I'm able to cancel 1 power of x plus 1. And in the second term, I'm able to cancel the factors of x plus 1 to the second power. I'll distribute on the right, collect like terms, and then use equality to determine the values of a and b. On the left, x has a coefficient of 1. This means that the coefficient of x on the right, a, must also be equal to 1. Also, on the left, the constant term is 7. This means that the constant term on the right, a plus b, must also be equal to 7. I'll solve my system. I know that a is 1 and a plus b equals 7. Using substitution, I'll replace a with 1 in the second equation and get that 1 plus b equals 7, which means that b is equal to 6. Thus, my partial fraction decomposition of x plus 7 divided by the quantity x plus 1 to the second power is 1 divided by x plus 1 plus 6 divided by the quantity x plus 1 to the second power.